Hello guys. So today we are going to start OSPF. So in the previous session we discussed about the RIP, that is Routing Information Protocol. So that is not covered in our CCNA syllabus, but still I have introduced you a little about that one. And before of that I have told you about the static route. So these are basically the routing information protocol. So they collect the routing information from the routers, that how they are connected and which of the routes are available to the destination. So based on these routing information or the routing tables, what are being built through these protocols, the packets are being sent based on this routing information. So let's go ahead with the OSPF. So we studied that in the RIP, we used our Bellman-Ford algorithm. Here, I think I have mentioned here that Bellman-Ford algorithm because RIP uses Bellman-Ford algorithm. But now we are not using that Bellman-Ford algorithm, so I should not mention that one. So that's why I have mentioned it, which is a departure from a Bellman-Ford algorithm. But actually, I have copied this paragraph from the Cisco website, so it was written over there. So I have just taken from there, and not a problem. But because OSPF uses our Dijkstra's algorithm. Dijkstra's algorithm for the calculation of the path algo. So RIP uses Bellman-Ford and our OSPF uses Dijkstra's algorithm. So OSPF protocol is an interior gateway protocol used to distribute routing information within a single AS. So we discussed it that whatever the IGP protocols we are having, they are used to share information within an AS. So within an AS means that AS is being sent to the routers of the same enterprise. So that's where we run our OSPF, right? So let's learn more about the OSPF and how it has been moved forward from the RIP. Because obviously, if we are learning a new protocol, then we should have to find out some loopbacks in the previous one. Then only we understand that why are we using that one. So the first thing, we are having the limitation of the hops in the RIP, 15 hops. So there is a no limitation in the OSPF. You can use unlimited number of hops. So that's just one problem we overcome with the OSPF. Another was that OSPF not was RIP was using the broadcast, but in fact I should say that RIP version 2 shot out this problem, and they were also using the multicast, and here OSPF also uses the multicast. OSPF uses the multicast for the routing updates or from the neighborship, because one router is being connected to another one, so that information is being sent over multicast or hello packets, or how we can find the other neighbor. So that information is being from the multicast. Another important aspect is updates are being sent in case routing changes occurs, right? So if we compare with the RIP, in the RIP, what was the option? There was an option of the periodic updates. That RIP was sending the periodic updates. It means that in a regular interval, it was sending an complete routing table, and it was sharing with the neighboring peer or neighboring routers. So using, because if whenever it is sending the complete routing table, it utilizes the bandwidth, right? So unnecessary our bandwidth is utilized, which is not necessary, because that other router might be having the same routing table, but is still we are sending again that information again and again. So that is just unnecessary utilizing our bandwidth. What is the happening in the OSPF, that updates are being sent in case of the routing changes occurs, that it will send just only in case whenever there is a change in the routing information. Means if any there is an update, suppose one of the network goes down or it is newly connected to our router, then only updates are being sent. And that's also just an update rather than the complete routing table. It just shares the updates only, that I have one new network connected or I have new route information, and that we will share from this router to this router. Just an update, it rather than sharing the complete routing table. So it just optimizes the our link bandwidth. OSPF has the better convergence time. So convergence time means that whenever our link is down, so how fast it can find the alternate routes. So that is faster in the OSPF. It allows the better load balancing. Load balancing is like whenever we are having multiple paths. Suppose this is R1 and this is R2, this is R3, this is R3, and this is R4. We have routers like this connectivity. And if you want to reach from router 1 to router 2, you have two paths, right? So this is called load balancing. Some of the packets go via this and some of the packets can go via this. So this is called load balancing. We are sharing the loads on these links or on these routers. So that is load balancing. So it allows the better load balancing. It is also available in the RIP, but it's some better control on the load balancing. Another and most important part is our metric. So in RIP, our metric was the hop count, because that's how we were finding the destination based on the hop count, that how much short hop counts we can reach the destination. And here the metric is our cost. Cost means that bandwidth of the link. So we have discussed in the previous session that how cost is calculated, that is 10 to the power 7 divided by our bandwidth, and that's how we, but that's also not valid, that formula anymore. We have some standard cost of that link. So it uses our Disgustas algorithm, and we also sometimes call it as the shortest path first algorithm. So router generates link state advertisement LSAs first, because suppose our router, they are connected like this, suppose. Right. So if they are connected via each other like this one, what is happening first to find out the router generates the link state advertisement, that how I'm sending you the information of my link. So suppose that router 1 is sending information to the router 2. It means like this one, LSA is being sent. And the same way it is being sent like this one, LSA. This router 2 will send that LSA information to this one, router 3. And this R3, whatever it has received from R1, it will send it to R4. And if it is router 2 is connected via R3 like this one, so what is happening, that router 2 will send that LSA once again, right? So this route R3 will discard it, because it will observe that that has already been received from the R1. So it will not receive that LSA as well, it will discard it, right? So this also helps to avoid the loops. That whenever we are receiving any LSA information, duplicate from any of the link, the router discard that information. So this is also done. All routers exchange LSA by flooding. So whatever is this phenomena is happening, because it is receiving and sending to other, that phenomena is called as the LSA flooding. Router calculates the shortest path to all the destination using the Disgustas algorithm. So once, suppose router 3 has received the LSA, it has received the LSA. Now what it has to do, it has to find out the shortest path to the router 1. So it will calculate the shortest path like this one, and it will use the Disgustas algorithm. So this is also known as the route, right? We sometimes we are also terminology as RTA. So not to worry, this is just a route, but it will calculate the path to the route, shortest path, that what is the shortest path to reach R1. So that's how it just finds the network topology, and based on this information it creates a routing table. So first it will create what is happening. First it is happening the LSA, all the link state information are being sent to the all the routers. Then routers create a topology based on this information, means that how the routers are connected, right? It will based on this LSA link states, all the routers create a topology that how all the routers are connected to each other, and based on that topology, whatever the best path we are having or best way to reach our different routers, that will make an entry on the routing table. So obviously that topology table is having the multiple entries because it may have the multiple route to reach any destination, right? But whatever will be the best one, shortest path first based on the discussed algorithm calculation, it will make an entry on the routing table, and the router takes the final forwarding decision based on this routing table only. You remember that we always check show IP route, right? Whenever we want to check any of the information, we just run this command show IP route, and that is just showing you the routing table, that what is the final decision of the router, that if any that destination we want to reach, then it will send to which of the router, right? So this is the same thing. This is the routing updates. Like whenever if there is no change in the network topology, there are no updates are being sent. So whenever this router 3 goes down, then only router 2 will send information to the R3 that R3 has gone down, and please don't send any packet, or if you send anything, then I will not be able to forward. It will delete that route from its routing table, right? And it will also calculate the topology, this table as well. We also calculate the database table. So if nothing is changing, nothing is coming and going up and down, so they will just simply taking the forwarding decisions. There's no change in the routing updates. Nobody will send any routing updates, and they are just simply sitting and just forwarding the packets, right? Whenever we are having a very large network, right? Suppose till now, let's say we are having just 4 routers like this one, right? So let's say this is a router 1, this is router 2, this is router 3, this is router 4. So this is just a small network. If any of the network goes up and down, right? So whenever it is going up and down, it is having just a limited updates that it has just to share all the networks towards that area, right? So this is just a problem in the OSPF, that whenever we are having the very large network and they are just connected to each other, in that case what is going to happen, that all this whatever the information we are having here, that is being sent to all the routers. Let's suppose this is R1 is going to up and down, so it will send an LSA to this one. This will send an update to this R4 LSA, and this will send to this. And obviously router 3 might have been aware of that one, but it is the large network, so there are a lot of routers connected over there, right? Like this one, or it can be anywhere. So what is happening, that this information that this network has gone up or down, that information is being sent to all the routers. Once this LSA is being sent to all the routers, now what has happens, that once LSA is being sent to all the routers, now all the routers will calculate shortest path to the destination, right? It means that that SPF algorithm will run again. Algo will run again, or we can say SPF algorithm is this disgusters algorithm. So this will run again. So there's two things are happening. The first thing is that this is unnecessary utilizing the bandwidth. I don't want to share that one of my own network is gone down. I don't want to share with the whole company that one of my network is gone down. So this is unnecessary wastage of our bandwidth, first thing. Another, it is just calculating this SPF algorithm every time once any routes is coming up and down. So running this discussor algorithm, it is taking the RAM and processing of the router. RAM and processing. So unnecessary, it is utilizing our RAM and processing of the routers, and it will make that working of that OSPF very slow. If your routers are not so strong and they are not the very high end routers, so they will be just not responding too quickly, or our OSPF will slow down. So sort out that problem. What we have done in OSPF, we have introduced the concept of areas, right? So what we are going to do, we are just going to divide that area in the smaller area. Suppose we are having just 4 routers here, like that one. So we will just make an area that, okay, these routers belong to this area. Another routers we can have like this one, just 2 routers like this one, right? If you want to connect more routers, then we can make another area, and that area can be something like that one, how their routers are connected to each other, right? So this is the concept of area. So now what is happening, that whenever any updates are happening, or any of the network is going down or up, something like that one, so now this LSA flooding is limited to the area only. Now it will not go outside of this information. Now it will not go outside. It's just limited to this one area only. So now what was happening, that a lot of LSA flooding and this SPF uh, calculation is limited to that one area only, or in fact we can say that the smaller number of routers. So now whatever we are having the problem of our slow or high RAM uses and processing, that has been sorted out of with this LSA. So let's just have a look what we have here written in the words. So that OSPF uses the flooding to exchange link state updates between routers. Any change in routing information is flooded to all the routers in the network. That's we have just discussed, that it is going to all the routers in the network. Areas are introduced to put a boundary on the explosion of that link state. That's also true. I have just discussed that one. Flooding and calculation of discussed algorithm on a router is limited to changes within an area. So now this discussed algorithm calculation will happen that within an area, not that will not go outside of that area. So that is this benefit of this dividing this OSPF in the smaller areas. And that is very most important part, that the routers in the same area are having the same link state database, right? All the routers within an area have the exact link state database, that whatever the routing information is having this router, it is similar to this one. This is also having the same information. This is also having the same information. While the other routers will be having separate routing table, and they will be having the separate information. This will be having then separate routing table. This will be having the similar to this one. They are having the same but different from this one. This is something X table, and this is Y table. This is also Y. This is also X. X. This is also X. So within an area, suppose this is an area 1. This is an area 0. And this is area 2. Right? So area 1, all the routers of area 1 will be having same routing table. All the routers of the area 0 will be having same link state database. And in fact, I should take this name link state database, not the routing table. Okay. And all the routers of area 2 will be having the same link state database. So they should be having Z database. So this is also Z database, and this is also be having the Z database. So I have taken one example via the pictorial representation, very good one. So let's see what are these. So we are having the large areas, like big OSPF area. Now we have divided that OSPF area in the 3 parts. The first area is area 0 that I have taken. area 0 is also known as the backbone area. Right? Area 0 are the backbone areas, and other areas are known as the normal areas. We don't have any name terminology, but yes, in all the, if you are running OSPF, then you must have this backbone area, area 0. If you're not having this area 0, you may not be running OSPF currently, and you may not use your OSPF. In fact, your OSPF will not be working. Right? So next thing is our IR routers. IR is known as the internal routers. So internal routers are the routers which belong to the same area. So whatever the router, suppose this is area, so this will be an I or IR, right? And if you talk about this router, this is also an IR routers. Why? Because it's both interface. This is also on the area of 2 and this is also on the area 2. What about this router? This router is having this interface on the area 2, these two interfaces on the area 0, so that the router which is having the interfaces in the different areas known as the ABR, area border routers, because this is in the border. It is just connecting two areas. This is going to the area 2 as well, area 0 as well. So whatever the router that is connecting the two, in fact the two areas, that are known as the ABR. So not in fact the two areas, that ABR should always be having one link towards the area 0. Then only we call it as the ABR. One link in area 0. It's not like that case that if you are having the any router and if it is connected on area 1 and area 2, then we will not say it as a ABR. We will say ABR only when it is one of the interface connected to the area 0. Fine. Next thing is our ASBR. ASBR is known as the autonomous system boundary routers. So these are the routers which are connected to our internet. So let's say this router, right? So this router is connected to our internet. So this router will call it as the ASBR. Or if it is not connected to the ASBR, so it is using the redistribution. It's like then static routes are redistributed on this router. So static routes or RIP or BGP or any of the protocols, uh, routing protocols, they are redistributed on this router 2. Then this router 2 will be ASBR. Don't worry, this redistribution I will tell you because I have not told you, so you might not be aware. And we have already discussed our backbone routers, right? So this is already done, backbone routers. So let's move further, that how to do the configuration part. So for the configuration, the basic configuration, you take one router, right? So what you have to do, just because here in the example I have taken the two interfaces, Ethernet 0 and Ethernet 1. In fact, Ethernet 2 is also there. So now what you are going to do, first just assign the IP addresses to all the interfaces like this one. And once you assign the interfaces, you have to just give this command for the router. So this is the OSPF part, because this is the basic configuration, I should say. This is the basic one. And for the OSPF, what we are giving the command, router OSPF 100, and this 100 is the process ID. So the command in the RIP, we used to give the command router RIP. Here we are giving the command router OSPF. And after that one, you just have to give the process ID 100. You can give any process ID like 10, 20, 1, or nothing like that one, right? So there's no hard and fast rule on that one. You can give any process ID. And then you have to give the network to introduce the interface to the router, that on this interface or OSPF is enabled. So let's see the configuration. I have taken an example of the packet tracer. So just let's have a look on that one. So I have not made any configuration, just created the topology and the labels on the routers. That's it. So let's start configuring our routers. So the first job is to configure the interfaces. So let's go the interface, enable config. I should have done this basic configuration, but I thought to tell you once again so that you get familiar with that one. But I recommend once again that please do practice these labs by yourself. If you do not do, you will never get confident. Yes, never get confident. So interface, I'm just configuring this 0 1/1 serial 0 1/1. Here I'm giving IP address 10.0.1. Here I have taken the IP 1.1 because the network is here is 10.0.1.0/24. So, and the subnet mask I'm going to take 255.255.0. I'm not taking the example as I have done on the previous one. I optimized the IP address for the simplicity. This time I have just taken the /24 subnet on all the router interfaces. So interface S01/0, and here the IP address will be 10.0.3.3 3.1, sorry, and the subnet mask will be 255.255.255.0. No shut. Here I'm just enabled this one, configured this 3.1, and the network was 10.0.3.0, and the IP addresses I have taken 10.0.3.1. So let's configure this router. I have not configured this. Let's do this G0/0 as well. Okay. So interface G. I have not introduced switch this time to not to trouble you too much. And here the IP address will be 10.0.6.1, and the subnet mask will be 255.255.255.0. No shut. So this is up. Now we have to configure the IP and the computers. We have not assigned on the computers, so we will do that once the routers are done. Let's do on CLI, must be powered on. Let's power it on. Sometime it happens. We have to power it on. So till the time, let's configure this one. This should be powered on. This is also not powered on, not a problem. Now both are powered on. You see, it is powering it on, so it is just booting up, right? It is just showing that final auto boot, and now it is okay. Let's say as no, enable config t interface Z0/0, right? And the Z0/0 is this one, this interface, which is connected to the computer. So here I have to give this IP 10.0.0, 10.0.5.2. So this side, because this is router side, so we have to give 5.2. 10.0.5.2. Subnet mask will be the same. No, oh, IP address I have missed. I missed a space this time. Yeah, no shut. And now I have to configure the remaining interfaces. This 0 1/1. So interface S0/1/1 IP address. Here the network should be this one 10.0.1.2. So IP address will be 10.0.1 and this one 1.2. So 10.0.1.2 and the subnet mask will be 255.255.0. No shut. And now about the remaining one, this interface S0/010. In this interface, we have to give the IP address 0 1/0, this one 10.0.2.0. This is right. That's what it is. Let me put it here like this one. Yeah. So this is IP in this interface 10.0.2.0, and we are on the router 2. So this 2.2, right? So IP address 10.0.2.2, and the subnet mask will be the same 255.255.0. No shut. And I think we're done with all three interfaces, and yeah, it's okay. So now we can go to the router 3 this time, and let's configure our router 3. So in the router 3, we have to write no first. Here enable config t and interface S01/1 IP address 10.0.2.3 255.255.255.0 no shut, and interface S01/1 IP address 10.0.3.3 255.255.255.0 no shut, and here we don't have any computer, so no third one. I think we have done the no shut 0.3 or 255. Oh, it is not up. It should be up, right? This 3.3, but it is still not. I think we are not given the no shutdown on this 3.1. Interface S01/0 no shut. No. Then what is the problem? Do show IP interface brief. We have given the IP address on this where we have given gigabit Ethernet is done. Series 1/0 3.1, and the status is down. Protocol is down 3.1. It should be right. Interface serial 01/0 no shutdown. Still not up. Interface serial. Sorry. We have taken the same interface here, right? In the router 3. 01/1 and 01/1. Okay, that's how it is wrong. So we have to take this interface as 01/0 like this one, and then we have IP address 10.0.3.3 255.255.255.0. Okay. It has taken the new IP address on the 0. So first we have to change on this 01/1. So interface S01/1 because it has taken the new IP address, this one, right? That 01/0. Oh yeah, 1/1 is having this IP address, this one, new IP address 10.0.3.3. That's why it is not taking on this 1/0. So first we have to change on the 0/0, no, 0/1, yeah. IP address should be here 10.0.2.3, and it should be 255.255.255.0 no shut. This is okay, and now we come to our 01/0 01/0 IP address 10.0. Here it should be 3.3 3.3 255.255.255.0 shut, right? So yep, it's up now. That's perfect. So now we have just configured the basic interfaces on that one. We have not configured the IP addresses on the computers. So let's configure that as well. Config desktop IP configuration. Here it should be 10.0.6. Can anyone tell me that do you have to configure the default gateway or not? What do you guys think? 6.10, and there should be 255.255.255.0. Anyone say that default gateway is required or not? Let's not configure and we'll see that does it ping or not. Okay, we'll see. But here we have connected to the router, but still we have not configured the default gateway. And let's say that whether it will ping or not, right? And on this computer too, let's configure IP address, this one, 10.0.5.10. Fine. And here I should give this subnet mask. And here also I'm not configuring any default gateway. Let's see that whether first let's just take ping, it's pinging or not. Ping 10.0. What was 5.10. 5.10. Now we are pinging from PC0, this PC to this PC. This is 5.10, right? This is the 5.10. So let's pinging, and it is getting the reply. It is saying that request timed out. Request timed out. Let's try to ping from here to this interface 6.1. Are we able to reach this 6.1 or not? Right? Because we are on this computer 6.10, we're trying to ping this directly connected interfaces. What are we able to ping or not? Ping 10.0.6.1. This is the interface of the router. Let's ping this one. Yes, we are getting the reply on this interface. That's fine. What about this 3.1? Means the other interface of the router, same directly connected router is the other interface. 3.1. Let's try to ping 3.1. 3.1. No, it's not pinging. You see, it's not pinging this time, right? Why it is not pinging? Because this router is not having this computer is not having any information that where to send that packet on this router, right? On this computer, this PC0 is not having any information that where to ping that packet, send that packet. If the packet reaches to the 6.1, then it should be able to ping that one. But let's try to ping the other interface 1.1. Ping 10.0.1.1. Is it able to ping? No, it will not able to ping. Why? Because our PC0 is not aware where to send the packet. What about the 6.1? 6.1 was able to ping because it was directly connected. Directly connected means that this computer knows, okay, 6.10, I have to send packet on this interface. What about the remaining networks? Remaining networks is not aware. So how to sort out this problem? We have to set the default gateway on this computer. That whenever you are having any issues and you don't know that network, that please send toward this router, that router will take care of that information, right? So let's configure the default gateway that for this computer, that if you have any issues on your computer and if you don't know any of the network, please send to this router. So let's give the IP address of this routers. That's a default gateway 10.0.6.1. You see, now we have given the default gateway that whenever you don't know anything, just send that towards this router. That router will decide that whether I'm connected to that network or not. Right now, what was happening? This computer was saying that, okay, that network is not reachable, and it was just saying you request timed out. But by this way, it will reach to the router first, and that router will just find out that whether I'm reachable further or not. So let's try to ping now. Let's close this one, open command prompt. And now we are going to do the same thing. We are trying to ping this 3.1 and 1.1. Okay. So first we take 3.1.1 and we see it is now pinging. What about 3.1? Yes, it's also pinging. Why it is pinging? Because now when I this PC0 is requesting packet, it is checking that, okay, this network is not connected to me, right? It is outside of my network. Outside of network means that I have to send to the default gateway. It just checks in your machine that is default gateway set or not. It just checks, yes, default gateway is set in my computer. It sends towards the default gateway. And now default gateway checks that whether I have connectivity towards interfaces 3.1 or 1.1 or not. So 3.1 checks its routing table. How it checks? It just checks that show IP route and it says okay 3.1 network, this is okay, this is locally connected or this is directly connected to me, so I can reach that one. So it just reach that 3.1 and get reply from that one. What about the 1.1? Same thing is happening for 1.1. 1.1 is also directly connected like this one, right? 1.1, and it also we are getting the reply. What about this 3.3? What about this 3.3? Or can we ping that 3.3? Let's check from the PC0. 3.3. No, it cannot ping because it has no information about 3.3. For that, there are three ways right now we are having. The first way is to configure the static route. Second way is used to use the RIP we have studied. And the third option, we are having the OSPF. So today we are going to use OSPF. Okay. So let's configure the OSPF on all three routers. And let's try to ping this as well, 5.10, because just for information, you can ping directly connected, which are because you have the default gateway, it means your packet is reaching up to this router. So the directly connected interfaces of this router you can ping, but remaining interfaces you cannot ping. All this all area will be your not reachable. So for that we have to configure the OSPF. So let's configure the OSPF, configure terminal, and the command was router OSPF, and we are going to use the OS process ID as a 10 this time. Okay. Now we have to tell that router that which of the interfaces are on the OSPF. So first we have to give this one. This interface is connected, this network is connected, and this network is connected. So what you are going to do, you have for that one we have command like network, which are the networks are connected, right? So first network is connected, this 10.0.1.0. So we have 10.0.1.0. After that one, by default you should get the wildcard mask it takes here, but you are not aware the wildcard mask. So right now I am just giving you the subnet mask. So subnet mask is 255.255.255.0, and you can put the question mark and they tell you that area, that this interface belongs to the which area. So today I'm not giving you the idea about the other areas. Right now we are going to configure all the routers in the same area, and that will be the area 0. So I'm giving the command area 0, that all this interface in the area 0. The same thing we are going to do for this network 3.1. So I'm just changing this here 3.0. That's it. And now we are same thing we are going to do all this 10.0.6.0. I'm advertising that network to the OSPF as well 6.0. So now all three interfaces are done. So OSPF configuration on this router is done. Nothing else is required. Exit. That's it. Means this is the OSPF configuration. That's it. Very simple. Same thing we are going to do on the router 2. Enable config T, and you can use other OSPF process as well on the different routers, but I'm using the same, not a problem. Router OSPF 10, and now I have to introduce you the OSPF networks. So the network, let me put it this side. Okay, let me add this one, then I will drag it the right side. So network, we can use the same command, copy and paste. Why it is happening like this one? Yeah. So network, and now we are going to tell this one 10.0.1.0, 10.0.1.0, 255.255.255.0. You can search in the Google that what is wildcard mask. You will get a little idea about that one. Although I'm going to cover that in the next video because this video is also going to too long. So now we are getting the message that loading is full, means that it has found the adjacency with this router 0. No, sorry, router 1. This is router 1. This is router 1. This is router 2 and router 3. So we have entered advertise this network on this router 2. So it has formed the neighborship. Now we can advertise this 10.0.2.0 network. So 2.0 and it will form the neighborship with this router 3. Just wait for few seconds and it will form the neighborship with this as well. I think we have not configured the router on the router thing, so it will not come up. And we have to advertise this network as well, 10.0.5.0. So 10.0.5.0. See, and that's it. Exit. The same thing we are going to do on the router 3. Enable config T router OSPF 10 network 10. We have to give two networks, 10.0.2.0 and 10.0.3.0. So 0.2.0 and the subnet mask will be 255.0 and I'm putting all in area 0. Same what happened. Oh, spelling mistake. Area 0. Same thing we are going to do with the area 3. And now we should getting the two messages that's neighborship coming up because it will come make the neighborship up with this 3 and 2. Yes, we're getting the two messages that the loading is full, right? So now let's check that are we able to ping our this 3.3 interface or not. And we get the reply now. So this is just magic of OSPF that we are able to ping. Not only this one, we can all the interfaces are reachable. Now you can now ping this 5.10 as well from here. 5.10. If it does not ping, then we will check why we cannot. We will troubleshoot that. Then you will learn the troubleshooting as well. And I think you are lucky enough to get the troubleshooting. Yes, we are not getting the reply because we have not set the default gateway on this router. I just got it. So we should get the default gateway on this towards this interface 5.2. So 10.0.5.2. Let's ping now from this one and we get it. You see? So that's how that's how we do not do to the troubleshooting because I just got in mind that we have not set. But the troubleshooting is like just checking the neighborship. How we do the troubleshooting? Let's check. So first command is to just show IP OSPF neighbors. So it just tell you that with the how many routers it has found the neighborship. So it has found the neighborship with the two routers, that 10.0.5.2 and 10.0.3.3, right? So that is okay. And on these interfaces, you can see the interfaces as well. From this router 1, it has one neighborship on this 1/1, this interface, and you have one neighborship on this 0/1/0, right? Another thing, you can check the show IP OSPF database. So on the database, it just shows you that how many areas you are connected. So you see that it is saying you the area 0 we are having, and that is saying in the router link states, right? And we are having the 3 link IDs through connected to this one. The first link ID is this 0.5.2, another is 0.6.1, and next one is just 10.0.3.3. Clear? That's perfect. And another thing, you can check the interfaces. These 3 commands we check for the interfaces: show, IP, OSPF, interfaces. So with the interface, you will get the maximum details. But sometimes we do not need this much of detail. Our neighbor and database helps a lot. But here you can see the full details: hello timers, dead timers, wait. So I will discuss in the next video that what are these timers and how does this help. Although they are similar to the SRIP, but the values are a little different. We have some more values. You can just go through that one, but I will discuss in the next video because this is going to be too long and it's not an easy to digest such a huge information in just one video, right? So I will take some more videos on this OSPF so that you can understand really. So, and the most important part, you can check the show IP route now. So whenever we see this information O means that we have received this route via OSPF. So we see that we have like two routes via OSPF, right? For the same destination 10.0.2.0, we can reach via 10.0.1.2, or we can reach via 10.0.3.3. So let's understand this concept. So we can reach via 10.0.1.2, this path, or we can forward that packet to where it says 10.0.3.3, means this path, right? Let me check the pen if I can open. It takes time although. Right? So either it can use this path, this one, right? Or it can forward the packet on this path. So either way, it can reach to the destination. Either it can go via this path, or it can go reach via this path. So it just depends, because we discussed about the load balancing, right? Load balancing. This is called a load balancing. We have the two paths. We can, but this is actually equal load balancing. Equal, because some of the packets will send on this one and 50% on that one. So that is the load balancing. Just not to worry too much, but if you have the routes, you just enable the OSPF and it will do load balancing automatically, not to worry. So I think I should stop here, otherwise you guys, because there's a lot of things to learn in the OSPF, we cover in the next session. But that is okay, and just to do the basic practice till now so that you can learn a little. Okay, so just whatever I have told you, just make a lab scenario like this one, or whatever you want, configure it, and if you feel any difficulty, just reach me one to one, or you can write in the comment section as well. I will reply back to you. And if you are running recently, you can also join our live sessions. Okay, thank you guys. See you in the next video with more details on the OSPF. Bye bye.